let's go. Yeah, today's class we're going to pretty much go through these 4 examples. 2 of them I asked you guys to do last night. I don't know if you had time to do it, but if you did, it'll be better. You'll kind of see the differences between what your intuition tells you to do versus what's probably more efficient. And yeah, we're going to learn a lot of lessons from these 4 examples. This one is just really a warm-up. The lesson really is for the other 3. And we're going to see some peculiarities of linear systems and learn about their properties. So this is very similar to one I already did in class, so we're just going to knock that out, and then we'll go through doing it for larger systems. So this process is called gauss-jordan elimination. I'll probably define that again at some point. But that pretty much means create an augmented matrix, use row operations to bring it to reduced row echelon form, and then pick off the solutions. By the way, if you have like a fancy graphing calculator, this is how your calculator solves systems of equations. So you type in these 2 equations, what it does is it creates a matrix. This is the augmented matrix. It doesn't put a line there, but that's for human beings to kind of visualize how things are going. So that is the start. Now, the goal is to get this into reduced row echelon form. What's off about it? So that's probably what you want to identify first. Yeah?
You need 2 zeros where there's 2 and -1 is.
Right. These 2 things need to be 0. So for a 2 by 2, at most, or at least. So this 2 is a problem, right? So let's deal with that one first. Can you tell me a legal way to kill that 2? Yeah.
Multiply the first row by -2 and then add them.
Okay, so take row 2 and minus 2 row 1 would be a way. Now this one is fine, so I pretty much don't do anything to the first row. I want to kill that one, so I want to change the second row, and I can change it based on this, which is a type 3 operation. And so this minus 2 times that, 0. This minus 2 times that, 3. This minus 2 times that, 6. Now, we remember the other criteria is that the first non-zero number in each row should be a 1. That guy's a 3. Is there a nice way for me to make that into a 1?
Divide by 3.
Right, multiply row 2 by 1/3, or same as dividing by 3. And that would be a 1, that would be a 2. Now, we're going to keep going. I do want you to appreciate, though, that here we actually have a row echelon form. And it's possible to solve a system from the row echelon form. It will require some extra work. Now, if you stop at the REF instead of the RREF, it's just called Gaussian elimination. But if you continue to reduced row echelon form, then it's called gauss-jordan elimination. Anyway, the procedure at this point would be start from the bottom row up. And this is going to be a general procedure. We'll do this for the other ones also. Translate to equations. and use substitution to find the variables. So, for example, the bottom row here is row 2. Now, according to row 2, what is the equation that row 2 gives us? Yeah?
Y equals 2.
It just says y equals 2, which is the value of one of the variables. We'll then move up to row 1. What does that equation translate to? X minus y equals -1. But since in the row lower than that I found the value of y, I can plug it in here. And then I would have x minus 2 equals -1, which tells us that x equals 1. And that's actually the solution. So you could actually stop here. You do have to do a little bit of algebra to get to the final answer though. But I want you to bring it all the way to reduced echelon form so you can actually find this a little easier. So if we want to go into reduced echelon form, what is the problem? Yeah,
Still have that -1 up there.
-1. That's that needs to be a 0. How can I make it a 0?
And you add row 2.
I take row 1 plus row 2, and 1 plus 0, 1, this plus that, 0, this plus that, 1, and leave this alone. Now you'll notice this is in reduced echelon form. First non-zero number in each row is a 1. The ones are to the right of the ones that are above them. They have zeros below and they have zeros above whenever possible. That's a reduced echelon form. There are no rows of zeros, so we are actually fine. And what you can tell from this situation is that you can kind of read the solutions right away. Right? So like the first one tells you x equals 1. 1x plus 0y equals 1. And the second row tells you y equals 2. So that's the solution. Like I said, this happens to be how your calculator would do it. You type this in, it translates to that, brings it to this form, it reads it, and then it outputs this on the screen. That's a 2 by 2. Hopefully that wouldn't be so bad. Once you get to 3 by 3s and higher though, efficiency starts to become an issue. There are times when I've written tests and I'm checking to make sure the questions are, they're doable in the time, and I'm like, okay, here's a 3 by 3 system. I do it with matrices. Okay, it took me 3 steps, pretty fair. All right, submit the test question and put it on the test. Then when I get the test back and I'm grading it, I see people like 15 matrices all over the place that they never actually get anywhere, and then they're like, no solution, because I can't find it. I'm like, that's not how you determine no solution. You are being inefficient. They're like creating zeros and then they do something to put it back, and it's like, it can get really hairy. Not many people get in trouble with the 2 by 2s, but once you go 3 by 3s, people's intuitions tend to start to fail them. So, which is why I kind of wanted you guys to try it for a few minutes before, see how you actually fared with the second example. But we'll actually go through it. Yeah.
You want a test, and you were to do it through a system of equations with the like x and y variables, and then translate that into a matrix. Would that be acceptable? No.
If you were what?
To do it through a system of equations, and then translate that system of equations into the matrices, just so you can understand it better.
It depends, but I'd rather you be able to do everything in matrices. There's going to be things that I'm going to ask you to do where the matrices way is the way you're going to have to do it, because it's not directly translated. So this is a skill you need to know how to do anyway. Let's look at so it's minus 2x plus y minus z equals 4. X plus 2y plus 3z equals 13. 3x plus z equals minus 1. Minus 2, 4, Did anyone actually manage to get through this? No? Okay, if I'm translating the matrices, what am I going to do? What does it look like? First row.
2, 1, -1, bar, 4. And then 1, 2, 3, 13. 3, 0, 1, -1.
Okay. So that's our augmented matrix, we call it. Now we want to bring that to reduced row echelon form. Okay, what are some of the properties of reduced row echelon form? What am I going to do? So here are my recommendations for making it a little bit more efficient. Really focus your game on the pivots. So those are the first non-zero numbers in every row. So step 1 is of course to augment. Step 2 is we're going to do row operations. Now, step 2B is to, here's how you're going to focus your plan of attack to make sure you're not running around spinning your wheels, shooting yourself in the foot, that kind of thing. You're going to establish the highest leftmost pivot. Okay. So you're going to get that leading one in the top row, right? That's going to be your goal. And of course, you know that they cascade off to the right, so the guy in the top should also be most to the left, which means I am going to want a pivot in this location. I'm going to want that location to be a 1. And of course, once that location is a 1, I pretty much want zeros below it. That's going to be another requirement, and which is what I would say first. So that should be an immediate goal, immediately, as soon as possible, usually within the next step, get zeros below. Most of the time this can be done in 1 step, at most 2. If you're taking more than 2 to get a pivot there and 2 zeros below it, you're wasting time. So, now remember, there are only 3 legal moves. I can swap rows, I can multiply a row by a non-zero constant, I can add a multiple of one row to another row. So now I'm going to think, of those 3 things, what's the easiest way to get a 1 right here? Yeah.
If you multiply the second row by 3 and add it to the first row?
That would do it. Something easier.
Swap it zeros.
Swap it. That's even easier. It requires no arithmetic, right? Swap these 2. Move row 2 to the top. Now I have my pivot here, which is good. In the very next step, I want a 0 here and a 0 here. Right? So I write that down before I even have it, you know. Kind of launch the prayer out there, make seem if something gets fulfilled. And then I'm going to figure out how to get that 0. I know I want that 0, but how can I get that 0? What's a way we can get this 0? Yeah.
Can you then multiply the original row 2 by 2?
Yeah.
And then add it to the first.
That can
row.
do it. So I can take 2 row 2 plus row 1. What's another way to get a 0? So using row 1 and row 2, I can get that 0 here. I need 2 other equations to get a 0 here. What else do you see?
Can you multiply the second row by -3. And add to the third row.
Okay, let's do 3 row 2 minus row 3. So now I even know what I'm doing before I actually do it, right? This is the strategy, right? So now let's actually do these calculations. So I'm going to take 2 times this row and then add it to that row. 2 times this plus that, 0. 2 times this plus that, 5. 2 times this plus that, 5 again. 2 times this plus that,
30.
30. There's my new second row. Now I'm going to do this operation. 3 times this minus that. So 3 times this minus that, 0. 3 times this minus that, 3 times this minus that, 3 times this minus that,
40.
40. So your second matrix should kind of have that form. You want the topmost pivot and zeros immediately below them. You take more than one step to do that, you're probably being very inefficient. You should be able to do this in one step. Now, step 3. Repeat for successively lower pivots. So I just got the pivot in the first column sitting very comfortably. My next goal is to now get a pivot in the first row. My next goal, get the pivot in the second row, get him to feel comfortable. Which means I'm going to want a 1 in this situation and a 0 in that situation. Right? So I know that's my next goal. Now, usually you want to do that in one step if at all possible, but sometimes it's not possible. Sometimes it's possible, but you don't really want to take the risk. Here we have numbers relatively big, but we can actually make them smaller. And so if you want to take an extra step to get smaller numbers, usually it's going to be worth it because, like I said, you're doing a lot of arithmetic. There'll be a lot of reasons to make a mistake. So let's just factor in an extra step here. Can I reduce these 2 rows somehow, legally?
Divide by 5 and then
Divide by 5 here, divide by
2.
2 here. So here I have the 1, 2, 3. First row is pretty awesome at this moment. I don't want to mess that up. But I can divide this by 5. So this is row 2 by 5. And I can divide this by 2. So you have, this is row 3 by 2. Numbers are a little smaller. By reducing, I actually get the 1 here, so that's good. So now I have the pivot in the first row, pivot in the second row, and that 3 is messing up the plan, so let's actually kill it, right? Legal way to kill that 3. Yeah.
Row 3 minus row 1 and row 2.
Row 3 minus row 1 and what?
And row 2.
What do you mean minus row 1 and row 2?
Fine, because there's 2 and 1 in the middle column. So 3 minus 2 plus 1 is 3. And that's 0.
Okay, of the 3 things I mentioned that we can do, is that one of them? You can swap 2 rows. You can multiply a row by a non-zero number. You can add a multiple of 1 row to another row. These are the only things you can think to do. Everything else is, yeah.
Row 2 times 3 minus row 3.
Yeah, I can get this to be a 3 and then subtract that, or even vice versa. So let's actually do that. I can take, let's say I'm going to take row 3 and minus 3 row 2. So I'm going to take this minus 3 times that, gives me a 0. This minus 3 times that also gives me a 0. This minus 3 times that gives me a 1. This minus 3 times that gives me a 2. Okay. Now, another comment here. There are many legal moves that you could make that wouldn't really help. So for example, let's say someone saw that, well, I multiplied this by 2 and that by 3, which is a type 2 operation, and then use this to subtract that, I can get a 0 here, right? That's actually a bad plan. Do you see why? Yeah.
Is the 1 on the top row still multiplied by
Right. This is going to be multiplied by 3, and if I subtract this, it's going to put a 3 here. So that 0 that I need to be in the right form, that I worked so hard to create, I would now undo that, right? So you need to make sure that whenever you're doing something, 1, it's legal, and 2, it's not messing up a situation that you already worked to create, right? So using row 2 and row 3 should be what you're looking at, because you don't want to mess up the zeros that are in front of that. Once you start to use row 1, you can mess up those zeros. So to eliminate this 3, I don't want to mess up the 0 that's in front of 3. I'm going to use another row that has a 0 in that position so nothing gets messed up. So using row 2 and row 3 is probably what I'm thinking about in the first place. I wouldn't even consider row 1 here, because I'm going to lose zeros and then that's not going to be a pivot anymore. So 2 and 3, I'm going to figure out what is a legal way to use these 2 to get a 0 in that position. And that's when you start to think, well, you know, swapping is not going to help, multiplying by a non-zero number is not going to help, type 3 is going to help, multiply this by 3, subtract that. And so now we're in this situation. Now, what makes this off from a reduced row echelon form? Yeah.
But I see zeros above as well.
We need zeros above, which means this 2, this 3, this 1 is a problem. I need to make those guys zeros, right? That should be the goal. So now, that's step 4. Once all pivots have zeros below, get the zeros above. Now I find it easier, again, none of this that I'm writing in green is set in stone, but I just find a human being who has this plan of attack in their mind will tend to be more efficient than not. And I would say start, now you start from the top down, get the top pivot, get to the second pivot, get the third pivot. Now when killing the zeros above, you're going to work from the bottom going up. Start at bottom most pivot and work up. So okay, I want to make this pivot comfortable. It means that's the first thing that's going to be in his way. I need a way to get that 0, and then I'm going to worry about killing the 2 and the 3. Yes?
So if I were to stop here and just be like, alright, now I know z equals 2 and I can substitute, would that be okay?
Yes. So you could stop here, say z equals 2, go up here, plug in 2, and then solve for y. Then go up here, plug in y and z, and solve for that. That would be fine in general, but it depends on the instructions from the problem.
Okay.
So if the problem was like, solve the system with matrices, no further instructions, yeah, you could stop here. But if the system says, use gauss-jordan elimination, or make sure to go to reduce Row-Echelon form before solving the system, this wouldn't be good enough. But yes, we could actually solve from here. This is actually in Row-Echelon form. And once you get to Row-Echelon form, you're good to solve. But there are cases where it's very important to go all the way to reduce Row-Echelon form, so I really want us to practice that. But for solving systems, it's optional. Let's go for it. How do I kill that 1? Yeah.
And subtract row 3. Row 2. Or not, you're not gonna do zeros.
Can I do that? Is that going to mess anything up? So if I take this minus that, that's 0. This minus that, that keeps the 1 here, which is fine. This minus that makes it 0. So that actually works. and then I'd have the 6 minus the 2, that's the 4. 0, 0, 1, 2. So now that's done. Let's focus on the 3. I want to make the bottommost pivot comfortable. So he needs to be the only 0 in his column. That's the rule. How do I fix that situation?
Row 1 minus 3, row 3.
So this minus 3 times that, this minus 3 times that, this minus 3 times that, this minus 3 times that is what? And these were fine. Right? So now what's the problem? Well, so this pivot, pretty good shape. That pivot, pretty good shape. This one though has a 2 in his column. We need to kill that too. So the next step is going to be, yeah,
You can do row 1 minus 2, row 2.
row 1 minus 2, row 2. We'll actually get that done. So this minus 2 times that, 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 and the others are fine. Now if you look at that, that is in reduced Row-Echelon form. Any rows of zeros are at the bottom, we don't have any, so we don't have to worry about that. First non-zero number in each row is a 1. The ones have zeros below them, they also have zeros above whenever possible. So that is reduced Row-Echelon form. Now in this form, can you tell me the answer? Yeah.
X equals -1, y equals 4, and z equals 2.
This is the solution. And again, you can get that just by looking at it. If you stopped here, you'd have to do a little algebra, plug things back in and solve for them. But that's it. And so, originally here we had the original augmented matrix, so we took 1, 2, 3, 4, 5 steps in this case. You shouldn't take more than that. I think yesterday we did it in 4 because we did like 2 things at once, which can be risky, but the numbers were small enough to get away with it. Let's actually... Any questions so far? So it's not a matter of the thing being difficult, it's a matter of knowing what's legal. There are only 3 things. And just doing it in an order so that you can get to where you want really quickly without messing it up along the way. That's basically what you want to do. And I think these steps that I wrote down, if you kind of keep these in mind as your plan of attack, you'll tend to be able to do that in the shortest amount of time possible. So, let's look at the other one. So, I'm not going to write out the steps for the other ones. Hopefully you kind of got those down and you're getting the intuition down. So, let's work on the other one, which I guess, since I ended here, I need to start it here. Let's just write down the matrix. I think you guys got the equation. So you're going to read off the coefficients and put it in a matrix. So it was 1 minus 2, 3 minus 2, minus 1, 1, minus 2, 3, 2, 2, minus 1, 3. Okay, so let's run through this quickly. My top left pivot is already a pivot, it's a 1, which means my next goal, 0 here, 0 here, in one fell swoop. How do I accomplish that?
You can, for the second row, you can take the first one, you can do row 2 minus 2, row 1. Or just minus row 1, I bet.
Or add them.
Yeah.
So you're going to take row 1 plus row 2. 1 plus a minus 1, 0. This plus that, minus 1. This plus that, 1. This plus that, 1. I also want a 0 here. How am I going to do that? Yeah.
Row 3 plus 2, row 0.
Row 3 plus 2, row 2. We'll get that to work. This plus 2 times that, 0. This plus 2 times that, 1. This plus 2 times that, minus 1. This plus 2 times that is 7. Next thing you want to do is you want to now, so this pivot is pretty nice. Next thing you're focusing on is that guy. You need to get that to be a pivot, which means I want to make him a 1 and get a 0 below him right away. Kind of want to do that the easiest way possible based on all the things that I could do. Now, I could just swap the rows, but the second row has smaller numbers in it in general than the last row. So I probably want to keep the numbers here and just multiply through by -1 would be pretty easy and keep me with small numbers. So 1 minus 2, 3 minus 2. Here I'm just going to do 0, 1, minus 1, minus 1, row 2 times minus 1. But I do want a 0 here, so how am I going to accomplish that? Yeah?
You row 3 minus row 2. Or is it?
Well, this is already
Plus.
a negative.
Plus,
So
yeah.
you
So
add them.
plus.
Row 3 plus row 2, row 2 plus row 3. 0 plus 0, this plus that. Those are both zeros. This plus that, that's another 0. This plus that, that's an 8. Now what?
Isn't it undefined or something?
Make note of something. It's like, hold the phone. What is that? Now that looks strange. Why is it strange? What does row 3 say?
0 equals
0 equals 8, yeah.
0 is equal to 8. That's not right. Right? That's not math. 0 can't be equal to 8. What does that mean? Did we make a mistake? Probably. If I see that, I probably made a mistake because that doesn't make any sense. So I go through, and the reason why we write this is for this kind of situation. You see something that's kind of off. You go through, okay, that's what I was supposed to do. Did I actually do that correctly? Okay, yeah, that's what I was supposed to do. Did I do that correctly? Yeah, that makes sense. And you go through, you make sure, yeah, I didn't make a mistake. And 0 equals 8. What do we do when that shows up? Then we say the system has no solution. Right? It can't possibly have an answer. There is no values for x, y, and z that I can plug into this system that makes all equations true at the same time, because if I could do that, it would mean 0 is equal to 8, which we know can't be true. So I can divide through by that to get 0 equals to 1, and I can use 1 to add up to any integer I want, so 0 is equal to every other integer. Then there will really only be one number, we kill the number system, then we kill math, everything's a lie. sky isn't blue. Yeah, everything's gonna mess up if we allow this system to have a solution. Yeah.
If that 8 was a 0, would you be able to continue going? Just hypothetically speaking.
We shall see. I actually have an example with that situation. But this situation is definitely not tolerable, right? 0x plus 0y plus 0z should be 0. It should not be 8. You would stop the process here and say the system has no solution. Which is, and so here are some remarks on this situation. A system with no solution is called inconsistent. It's inconsistent with the rules of math for this system to have a solution. A system with some kind of solution. Now that's a very weird phrasing. You might wonder how many kinds are there? It's called, of course, consistent. Now you also might be worried, how am I going to know when a situation like this happens if something like that didn't indicate itself? How do I know what I'm working on doesn't actually have an answer? The good news is that is the only way. So if this happens, something like this, you have a bunch of zeros equaling something not 0, it means the system has no solution. In every other case, there is some kind of solution. So you don't really have to worry about looking out for anything other than that particular situation. So you have a bunch of zeros, and then over here, you have some number where a is not 0. Once that situation shows up, it has no solution. And it will only ever show up if there's no solution. In every other case, there is a solution. So if someone does all these matrices, nothing like that shows up, and their answer is, oh, system has no solution. I know they do know what they're talking about. There's no, that is the only way you're going to know. It's the only thing you have to look out for. Yeah.
So I did a different first step that was still legal, right? So I didn't get the 0008 on the bottom.
Okay.
But, so I'm just kind of stuck, and there's nothing I can do.
What did your first step?
My first step was row 3 minus 2 times row 1.
Okay, so tell me what you got to what it looked like.
My last box was, my last matrix was on the top 1, -2, -3, -2, and then 0, 1, 5, -1, 0, 0, -6, and 11.
Oh, something is definitely off there.
Yeah.
Because that would have a solution. Oh, you copied it down wrong. That's supposed to be a +3.
Yeah.
Yeah.
Oh.
Yeah.
That'll do.
Step 0, be sure to check your, like even when I was copying on the board, you saw me sit there and read the paper over again. Some stuff like that happens all the time. But if it were a -3 and you got that, then your goal would be to kill this, kill that, kill this.
Yeah.
Starting from the bottom one, moving up. But yeah, you had a sign off. Let's look at the last one. And I'm going to just copy the double checking what you copy down, something I learned the hard way. there's a class named linear algebra, which it's an entire class on applying stuff with matrices. And so we were doing a lot of row reduction, and I just lost a lot of time making a lot of silly mistakes. And a lot of the times was because I copied the numbers down. Well, the kind of procedure that I said you guys should do, that's just kind of something I stumbled on. I never actually saw a book that actually said, here's how you kind of do it efficiently. They just say, yeah, just use row reduction and move it here. And they never really said what they were thinking while they did that. I think the procedure I laid out for you is a pretty solid way to go. I get things done pretty quickly. The quickest I've ever seen doing it that way. Let's continue. So, top left pivot, that guy's already fine, not going to do anything. I want that to be a 0, so I'm going to think add row 2 and row 1. This plus that, 0, this plus that, minus 1, this plus that, 1, this plus that, 1. I want that to be a 0, so I can do 2 times this added to that. So 2 row 2 plus row 3. I can get this plus 2 times that. This plus 2 times that, this plus 2 times that, this plus 2 times that, so I got that. Now I know I'm going to want to pivot here and 0 below it, so I can do 1 minus 2, 3, minus 2. Move row 3 up here, numbers are nice. And I can just add these two. So I'm going to take row 2 plus row 3. This plus that, 0. This plus that, 0. This plus that, 0. This plus that, 0. Okay, now I have a row of zeros. Now, is this something to be worried about? Yeah.
Let's say no.
Yeah, because 0 is equal to 0. It's not very helpful, but there's nothing wrong to say that technically. So I will approach this being a little cautious, but let's keep going. It's not in reduced echelon form yet. I need to kill this guy. So you're a little bit strange, but let's keep going. It's not wrong to say 0 equals 0. So I put those 2 rows back, and how do I get that to be a 0? Ideas?
Multiply the second row by 2.
Yeah. Row 1 plus 2, row 2. So this plus 2 times that, 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 I have that. Now this is in reduced or echelon form. Row zeros are at the bottom. First non-zero number in each row is a 1, and that 1 is the only 0 in its column. And they cascade off to the right. Now that row of zeros isn't particularly helpful. So again, we start from the bottom row up. What does row 3 tell us? Well, row 3 tells us 0 equals 0. Well, no information there. Thank you, Captain Obvious. So we just keep going. Row 2, what does row 2 tell us? Well, y minus z equals minus 1. Now here's how I want you to think of the pivots. Pivots kind of tell you who the subject of the formula is going to be. Remember like when it was like 1, 1, 1 and zeros everywhere else? The 1 told me that, okay, in this row I'm going to solve for the z, in that row I'm going to solve for the y, in that row I'm going to solve for the x, etc. Apply the same principle here. The pivot is in the y's column, so I'm going to solve for the y. So that's going to be my y. And if I move over to row 1, I get x plus z equals minus 4. The pivot is in the x column, so I'm going to solve for the x. And this is my solution. Now, what is the z?
Is it 0? No.
No.
No, there's no equation that tells me z is 0. In fact, there's no equation describing what z is doing at all. So you know what? I'm going to be more of a Captain Obvious and be like, z equals z. It can be whatever it wants. Here, we call z the variable with no pivot in his column. A free variable. He can pretty much do whatever he wants. He can take on any value he feels like taking on that day. This guy's free to do as he pleases. Now, the thing is, once z makes a choice, your x and y now has no choice. Whatever value is chosen here has to be placed here and here. And so, choosing a value for z forces values for x and y, in the sense that the solution is going to be the following. And you can come up with some solutions. Let's say z equals 0. Well, what does x have to be? Well, -4. What does y have to be? -1. If you plug in those three numbers into the system of equations I gave you, it will make sense. If I said, okay, z equals 1, what would x have to be? Well, it would have to be -5. What would y have to be? Well, y would have to be -2. If you plug in that list of numbers into the equation, it will be a solution. You can try it for yourself. I could say z equals pi. What does x have to be? Well, -4 minus pi. What does y have to be? Well, -1 plus pi. And if you plug those numbers into that system of equations, all equations will actually work out. Kind of get the idea here, right? How many solutions is represented by this situation? There's an infinitely many solutions. Now, this is something I'll write down in next class, but this is all, these examples illustrate all possible situations. If you're faced with a system of equation, you can have no solution, you can have one solution, and the next step up is infinitely many solutions. It's impossible for a linear system to have 5 solutions exactly. Not possible. You're going to have 0, 1, or infinitely many. We'll talk about that in a little bit. Learn some more.
Yeah.
Sorry, I forgot to give it.
I should have asked. I have a question. This isn't